Okay, so now we do question 15.5. So question 15.5 is about a Bertrand equilibrium where firms are competing over the prices. So the question giving you the quantity produced by firm 1 is a function of the price of firm 1 and the price of firm 2. Okay, so this is the case where it's different from what we did before, in the sense that firm are able to set different prices, and therefore firm will be competing over the price in order to capture the maximum profit. So similar, Q2 will be equal to 1 minus P2 plus B of P1. Okay, so firm will be competing in the equilibrium by choosing the price in order to maximize the profit for each of the firm, and they will be making the decision simultaneously, just like similar to what we did for the quantity decision. Instead of that, now firm will be choosing the price simultaneously in order to maximize the profit. So we pretty much will do the same thing. So we do for firm 1 first. Firm 1 will also try to maximize the profit of firm 1, but now they will be choosing P1, and the profit will be the price multiplied by the quantity and minus the cost. In this case, question telling you firm have no costs of production, so there isn't any cost of production, right? So which is equal to P1 multiplied by Q1 because there are no costs. Okay, so P1 is the variable that the firm will be choosing, and Q1 is a function of P1 and P2, so that 1 minus P1 plus B of P2. Okay, so firm will be choosing P1, taking P2 as given because the firm wouldn't have any power to affect the decision made by the other firm. So similar to the quantity decision like what we did before. So I expand this, I will get P1 minus P1 square plus B P1 P2. Right, so firm now will be choosing P1 to maximize the profit. The first order condition is if you differentiate the profit function with respect to P1, make it equal to 0, you will be able to find the values of P1. So if I do that, I get 1 minus 2P1 plus B of P2, and will have to be equal to 0 for the first order condition. Therefore, I rearrange it to divide the values of P1. Now remember, P2 is just a number in this case, which is something given to firm 1. So if firm 1 will be choosing P1 according to the values of P2 that's chosen by the other firm. So P1 will be equal to 1 plus B of P2 divided by 2. And this is called the best response function of firm 1 in terms of the price. Okay, now similar for firm 2. Firm 2 will also maximize the profit for firm 2 by choosing the price P2 and the profit again, which is equal to P2 multiplied by Q2 because there are no cost of production. P2 is the variable that firm 2 want to choose, and Q2, which is equal to 1 minus P2 plus B of P1, and expand everything, I will get P2 minus P2 square plus B P1 P2. Okay, so the first order condition again, which is be equal to 1 minus 2 of P2 plus B of B and P1 and equal to 0, and therefore P2 will be equal to 1 plus B P1 divided by 2, and this is called the best response function of firm 2 in terms of the price. Okay, so just like before, so I'll call this is the first equation, this is the second equation. So now we have two equations, we have two variables that we have to solve for the values. which are P1 and P2. So that very straightforward will be solving two equations simultaneously because firms are choosing their prices simultaneously. Okay, so I think I can do it. I substitute the second into the first, just like what I did before. I will be able to get P1 equal to 1 plus B P2 is 1 plus B P1 divided by 2 and the whole thing divided by 2. So if I multiply both sides of this equation by 2, I'll get 2P1 equal to 1 plus B, 1 plus B of P1 on 2. Again, multiply both sides of this equation by 2, I'll get 4P1 equal to 2 plus B squared P1. So from here, if I move everything, I move every P1 to the left hand side, I'll get 4 minus B squared P1 equal to 2 plus B, and therefore P1 will be equal to 2 plus B divided by 4 minus B squared. Now here you can just leave it like this, but if you look at it carefully, you can see that we can simplify it a bit more. So that becomes 2 plus B, still same, the denominator. If you remember the formula a squared minus b squared, that will become a minus b multiplied by a plus b. So here it will give you 2 minus b times 2 plus b. Okay, so that will give you 1 divided by 2 minus b. So that is the quantity, so that is the price chosen by the first firm. So using the second equation, you will be able to derive the price chosen by the second firm. So the price P2, which is equal to 1 plus B of P1 divided by 2, and that will be equal to 1 plus B P1 is equal to 1 divided by 2 minus B, and the whole thing divided by 2. Okay, so that will give you 1 plus B on 2 minus B, something divided by 2. So if I simplify this, I will get 2 minus B plus B on 2 minus B, and that will just give me 1 divided by 2 minus B. Okay, so that's exactly the same with the price that can be set by the first firm. Okay, so that is the Nash equilibrium prices chosen by two of the firms. Maybe compute the firm output and the profits. Okay, so we know the price P1 and P2. Substitute back into the quantity function, you will be able to find the quantity chosen by each of the firm. So quantity Q1 equal to 1 minus P1 plus B of P2. So I'll put a star here to indicate that equilibrium. So I should have a star here, and I should have a star here. Okay, to indicate equilibrium. So I already found P1 star and P2 star. Substitute back into this function here. I will be able to find the quantity Q1 star. So that is 1 divided by 2 minus B plus B multiplied by P2 star, which is 1 on 2 minus B. So that will just give me, so if I make 2 minus B as the common denominator, I will get 2 minus B minus 1 plus B, and that will just give me 1 divided by 2 minus B. Okay, so similar for Q2 star. That will be equal to so 1 minus P2 star plus B of P1 star, and that which is equal to 1 minus of 1 2 minus B plus B of P1, so that B on 2 minus B, so that will become 1 2 minus B. Okay, so the total quantity you're going to be produced in the market is going to be 2 divided by 2 minus B. And the profit for each of the firm, the profit for firm 1 will be the price of firm 1 multiplied by the quantity of firm 1. So that will be 1 2 minus B square. Okay, so that will be 1 2 minus B square. So similar for firm 2, the profit for firm 2 will just be P2 star multiplied by Q2 star, and that will should be equal to 1 divided by 2 minus B square again. Okay, so part C represent the equilibrium on a bed response function diagram. So again, the question asking you to draw a bed response functions for both the firms on a diagram, and then show an increase in B will affect the equilibrium. Okay, so we'll be doing that. So I got here a P2 0, here is P1. I want to draw the bed response functions for both the firm. Okay, so I know that the bed response function for firm 1 is P1 equal to 1 plus B of P2 on 2, so that which is half, plus B on 2 P2, and the best response function for firm 2 is P2 equal to half plus B on 2 P1. Okay, I already got P2 on the vertical, P1 on horizontal, so same like before, will be easier to draw the best response function for firm 2 first. Okay, so the vertical intercept, which is equal to a half, and the slope, which is equal to B on 2. So we know that it is upward sloping curve now because we have a positive slope, and I don't know the values of B, so I'll just draw a random line, which is basically straight line going up like this. Okay, so this is the best response function for firm 2. Now in order to draw the best response function for firm 1, again I want P2 on the vertical, P1 on horizontal. So in order to draw the best response function for firm 1, you will just have to rearrange the function a bit in order to make P2 as a subject. So if you rearrange it, you will see that P2 will be equal to 2 of P1 minus 1 divided by B. Okay, so you get negative 1 on B plus 2 on B P1. So that is the best response function for firm 1 in terms of P1. Okay, so with P2 as a subject. So as you can see, the vertical intercept is negative, so it will start somewhere down here, somewhere negative. Okay, and the slope is 2 on B. So I don't know the values of B, but then okay, so the question telling you that B is bigger than 0, right? Yeah. Now again, the condition is the slope. So I'll just draw it first. Okay, so this is gonna be the best response function for firm 1. Okay, so again, I don't know the values of B, but the condition is the best response function for firm 1 will have to be the curve will have to be steeper than the best response function for firm 2. Now, because if the best response function for firm 1 is flatter, you will see that there won't exist any equilibrium. So there won't be any intersection between two best response functions, and we won't be able to find equilibrium. Okay, so in order for the equilibrium to exist, the slope of the best response function for firm 1 in this case will have to be bigger than the slope of the best response function for firm 2. Okay, so I'll just have an intersection here, and this is called the Bertrand equilibrium. Right, so the firm will be choosing P2 and P1 according to this equilibrium here in order to be maximizing the profit in the Bertrand equilibrium. Now, if we have a change in B, so if we have an increase in B, what would happen? So you can see B here, B appears in both of the best response functions for both the firms. So when B increases, the best response functions for both of the firm will be different. Okay, so we do for the best response function for firm 1 first. Now looking at firm 1, you see that the vertical intercept here is -1 on B. So if now B is increasing, 1 on B will be decreasing. So I mean the number will be smaller, and remember we got a negative here, so if the number is smaller, negative of that number will be so basically we'll have a bigger number. Okay, so it's closer to the origin. So say we have here is -1 on B dash. Okay, so where B dash is bigger than B, so if B is increases to B dash. Okay, so and how about the slope? So here the slope will be 2 on B. If B increases, 2 on B will be decreasing. Okay, so the slope will have to be smaller for the best response function for firm 1, and if the slope is smaller, you know that the line will have to be flatter. So the best response function for firm 1 will be rotating to the right. Okay, now it's still going through the horizontal intercept here. If you want to see, so horizontal intercept is where you make P2 equal to 0. Now if you make P2 equal to 0, you can see that P1 is always equal to a -half, no matter what values of beta, no matter what values of B is. So here is always equal to a half, and therefore even though B increases, the horizontal intercept here won't change for the best response function of firm 1. So therefore we'll be having something like this. So I start at the new vertical intercept, but the horizontal intercept is the same, and the slope will have to be smaller. Okay, so the curve will have to be flatter. Okay, so we'll have something like this. So you see the best response function of firm 1 dash. So that is the new best response function. maybe I'll use a different color to indicate it. Okay, so that's the new best response function for firm 1. How about firm 2? Looking at this, the best response function of firm 2 vertical intercept is a half, so it's not affected by B, so a vertical intercept will still be the same. Okay, so start at the same vertical intercept. Now about the slope, when B increase, the slope will increase for the best response function of firm 2. So where the slope increase, the line will be steeper. Okay, so sorry, so I should be drawing this one in the sense that it will so that we will have an equilibrium later on. Okay, so I should be drawing it in the sense that it will be flatter than the original best response function for firm 1. It's not that flat, so we will still have an equilibrium later on. So I'll be having something like this. So I'll start at the same horizontal intercept and sorry. And it should be like this. Okay, so it shouldn't be too flat, otherwise we wouldn't be able to find any equilibrium anymore. Okay, so it rotates to the right but only a little bit like this. So this is the new best response function for firm 1. So best response function for firm 1 dash. Okay, like I said before, the best response function for firm 2 is starting at the same vertical intercept but gonna be a bit steeper than the original best response function for firm 2 because the slope is now bigger. Okay, so I'll draw something starting from the same vertical intercept. Okay, but it's gonna be a bit steeper than the old one. Okay, so say that is, so this one here is the new best response function for firm 2. Okay, so as you can see, this is the new equilibrium. So this is the new Bertrand equilibrium that we will be able to find. Okay, so that is how an increase in B will affect the equilibrium, affect the Bertrand equilibrium. Now the question also asks you to draw an isoprofit curve for firm 1. Okay, so isoprofit curve, again, the idea is the isoprofit curve is the curve including all the combination between P1 and P2 that will give firm 1 exactly the same profit, and that's gonna be a convex curve, something like this. Okay, so I'll say this is the isoprofit for firm 1. Okay, now in order to see why the why it is a convex curve like this, the easiest thing to do is to substitute the values of P1 and P2. Substitute to rely on the profit function here in terms of P1 and P2. Okay, so for example, I got the profit for firm 1 equal to P1 multiplied by Q1. Now there isn't any cost, so I don't need to worry about a cost. P1 here, and I know that Q1 is a function of P1 and P2, so Q1 is equal to 1 minus P1 plus B of P2. Okay, so now I have a profit of firm 1 is a function of P1 and P2 So that which is equal to P1 minus P1 square plus B P1 P2. Okay, ISO profit is the profit curve corresponding to a certain level of profit. Okay, so for example, I make this one equal to a number, so say equal to 10 for example. So you can come up with any number, doesn't matter. Okay, so now any combination between B1 and B2, P1 and P2 that's satisfying in this equation will give you a profit of 10. Okay, so that is the ISO profit curve. So the ISO profit curve will be the curve telling you on a combination between B1 and P2, which is give the firm exactly the same level of profit. So here you got a function of P1 and P2. I'll just have to rearrange this thing to make P2 as a subject because I want P2 on the vertical axis. So P2 in this case, which is equal to P1 minus P1 square minus 10 divided by B of P1. So that will give you 1 on B minus 1 on B P1 square. P1 minus 10 on B P1. Okay, so I want to draw this function here on the graph. I got P2 on the vertical, P1 on the horizontal. Now if you want to draw this, easiest thing is to find a stationary point, basically find a maximum minimum point and see whether the curve is concave or convex by doing the second derivative. So you're doing the first derivative to find a stationary point, doing the second derivative to find the concavity or convexity of the curve. And if you're doing that, you'll be able to see that the curve is convex, and you'll be able to find a minimum point of the curve somewhere. Okay, so that is the way for you to draw an ISO profit curve for a firm. So you can just take any profit level and then draw a function of P2 in terms of P1. Okay, so again, the higher the curve, the higher the profit for the firm. So it will be going, the profit will be increasing in that direction. And the reason for that is because for any higher, so say I got another level of profit here, then the profit for firm 1 dash, the profit for firm 1, then the profit dash will be bigger than the profit pi 1. Okay, so the higher the curve, the higher the profit. And the reason is because for exactly the same level of P1 corresponding to pi 1 dash, that's basically the higher level of P2. Okay, so as you know, if P2 increase, the quantity of firm 1 will be increasing. Okay, so if P2 is higher, Q1 will be higher, and at exactly the same level of price, if Q1 is higher, the profit for firm 1 will be higher.